Hello, this session is from the GCSE Study Club over half term. Our focus has been on chemistry, looking at different areas, and one of the most notorious topics on a paper 1, Unit 4 chemical changes, is electrolysis, and this is very valid and vital for combined sciences chemistry and separate chemistry GCSE, and it's specific to AQA but useful for all exam boards. So I recommend that you make some notes as you go through. You can pause. There are some accompanying slides, so I would get those as well. There are a few tasks. So the whole point of this is it's a mini tutorial. You can start and stop it as you please, and I would recommend watching it a couple of times as well. So I hope you find it helpful. Okay, great stuff. So if we get stuck in to what you need to know in terms of the basics and the bare bones of electrolysis, is to be able to actually define the key terms and stages with electrolysis, understand what the actual word means, being able to describe how, as a method, it is used to extract metals from a compound, and specifically what type of compound that is, which we'll look into. And also be more familiar and understand the different reactions that can happen at the electrodes with relation to half equations. That tends to be a particular area that gets asked in exam questions. The higher end, more higher demand exam questions, however, they are notoriously trickier. So it's really good to practice these. Okay, this is an activity and a task you can do yourself. I'm not going to go through it, but I am going to provide the answers, and also they will be in the slides. So just a bit of an activity for you to start and stop with yourself, as you can see there, and that will also be in the slides. You can email me for those. Okay, so exactly what is electrolysis? So think about the word and break it up. Electro and lysis. The electro bit is pretty straightforward. It relates to electricity. Lysis, you may have heard of with regards to cells, but basically means splitting. Okay, so this is the splitting of an ionic compound by electricity. That's what it means. And the diagram that you can see, you should be familiar with from the required practical that you will have done at school. So very, very importantly, you must be very clear that it's always ionic compounds, and thinking about why that is. Okay, going back to ionic bonding, periodic table, thinking about what different elements are where. So the majority of elements on the periodic table are metals. So the left-hand side and the middle are pretty much metals, which is most of the periodic table, and then the top right-hand corner are your non-metals. So ionic bonds only happen between a metal, which forms positive ions, and non-metal, which forms negative ions. The two together form a compound. This is crucial and important, and understanding the definition of an ion is super important here as well, because ions are free to move, and you can see you've got a cell and batteries here, so a current is flowing when that's switched on, and that is vital. That current only flows because the ions move, they're mobile, and they have charge. Okay, so the ionic compound itself must be in its melted or molten form, or dissolved in water, and therefore in an aqueous solution, and the ions are then free to move. So if you know the definition of an ion, I'd write that down. Okay, definitely we need to be clear on that, and all of chemistry. It is basically an atom that has gained or lost an electron, and if it's lost an electron, it's therefore positive and therefore a metallic ion, and if it's gained an electron, it becomes negative and therefore is a non-metal. Okay, so if we have a little look here in the beaker, the example of the practical here, it's really important to know that that liquid, which is either molten or aqueous, conducts the electricity. Okay, and that's known as the electrolyte, and it's the electrons within there, not the electrons, the ions within there, that allow there to be a flow of current. So as a definition, you can see there in the box in yellow, understanding that it is the breakdown of an ionic compound or substance with the use of electricity, with electric current. So there you've got that defined. So these are all perfect candidates for flashcards. So pause and make notes as you wish as you go through. Okay. So we Also need to be able to identify. Quite a few questions about labeling and identifying parts to do with the required practical. So the electrolyte itself is either molten, therefore melted from a solid to a liquid, and so it's changed the state of matter, or it's dissolved in water. Equally, it's liquid, but you have to note whether the information in the question refers to a molten compound or a solution. And so the positive ions will always move to the negative electrode, and knowing that the negative electrode is called the cathode. Again, classic flashcard candidate there. And therefore you have the opposite on the positive electrode. The negative ions will move towards it, and knowing that the positive anode is, or the positive electrode is known as an anode. Okay, one way of remembering it, if these things work for you, this is a good example, panic. So again, super flashcard. And learn that comes up all the time. Okay, some key terms and definitions. So again, you've got these here as reference. Learn these. You need to write them out. Pen on paper allows you to learn these. You can't just read them, it's too passive. Notes, mind maps, flashcards. There is a required practical here that I recommend that you watch as well. And again, make it active. Don't just watch it. Watch it once, watch it a second time, and the second time you watch it, pause as you go through, draw diagrams, label things, make notes. Okay, so here we have an example, what is made during the electrolysis of lead bromide. Okay, so we have the molten lead bromide. So this is an example that comes up in exam questions, and therefore it was a solid and it's been heated to a higher temperature and therefore has become in its liquid state and therefore is molten. And the lead ions in lead bromide, lead is a metal, has positive ions, will move towards the negative electrode. And that is where the solid lead will deposit. And that is the extraction of lead from the ionic compound lead bromide, and therefore can be then collected and extracted. Whereas on the positive electrode, the bromide ions will move towards them, Br minus ions, and be attracted to the positive anode. So in that format, while they're moving, they're in an ionic format, they have a negative charge and they go towards the positive electrode. Now, once they get there, and there are a number of them, they will form bromine gas, and therefore a molecule. So bromine gas is Br2, and that is two atoms, no longer ions, but atoms of bromine that bonded together that form a gas, and they form at the anode. So some examples here. Again, you don't need to commit these to memory. It's more about understanding. When you get an example of any of these ionic compounds, then you can apply your understanding. So noting that these are some examples of molten ionic compounds. So you've got the metal, then you've got the non-metal, and you can see which goes to where. Okay, so that's fairly self-explanatory. The key thing to note is obviously the name of the ion, of the negative ion, chloride, oxide, fluoride, bromide, and so on. Once the actual product has formed, as in a gas, then the naming is very specific. It's chlorine gas, oxygen gas, fluorine gas, and so on. And therefore you have to have that correct language and the correct spelling in order to get the marks, because a chloride ion is not the same as chlorine gas. Okay, half equations that you need to be familiar with. We think about the negative ions, knowing that they are attracted to the positive ion, anode rather, and the negative ions will lose electrons. So again, classic notes, get this right, flashcards. We can describe these negative ions as becoming oxidized, and here is a classic example. So two chloride ions, okay, they move towards the positive anode and they will form chlorine gas, Cl2. And as that forms, two electrons are lost and you have 2E negative, and that is your half equation. Another example, but on the opposite, on the positive, we have a situation where the positive ions move to the negative cathode and the ions will gain electrons. So they are positive, they gain the negative electrons and therefore become balanced out. Okay, And so we can describe the positive ions as being reduced. And a good example here is copper 2+, a metal. If it gains 2 electrons, therefore balancing out and becomes atomic copper, and therefore has no charge because it's an atom now, or series of atoms, and no longer ions. A similar task or activity here, again, you can write a table out looking at similar ways, but we have a mixture of different elements, chlorine being a non-metal, aluminium being a metal, copper being a metal, and so on. So being really familiar with your halogens is really, really helpful here, and being familiar with knowing whether something is positive or negative as an ion is very crucial. So we can see that chlorine will form at the anode, and you can have the half equation, and that is described as being oxidized, whereas aluminium positive ions will move or form at the cathode, and therefore will gain the electrons and become solid aluminium atoms, and therefore is reduced. And obviously you can then see that pattern as you go through the process. So you could write the table out as it is. A little change might be to have the substances that form negative or positive ions separately in the table. That might be really helpful. Also thinking about hydrogen. Now this is an exception to the rule. It does form positive ions. It is not a metal, okay, but it's a very simple atom, and it forms positive ions, and therefore is reduced. And when hydrogen gas is produced, H2. So some examples of some questions that you might come across: completing a half equation for the production of aluminium at the negative electrode. So you're given that something is going to gain 3 electrons. It's going to be the ionic form of aluminium, aluminium 3+. Those two combined, and therefore you get atomic aluminium. There we go, just Al. Now these are a bit trickier, 2, 3, sometimes 4 mark questions when you need to explain why the electrolyte used in this instance is in a mixture of aluminium oxide and cryolite. So that is what the electrolyte is made up. It's a mixture. And again, this is factual. You just need to learn it for aluminium oxide being electrolyzed. And therefore the cryolite is a substance that's added, and it lowers the melting point. So this is a big industrial process. It uses lots and lots of energy, and therefore is expensive. So if we can lower the melting point, then the aluminium oxide will become molten sooner, and therefore a shorter amount of time, and therefore it's cheaper to be able to do so, and that is because of the cryolite. And so there is less energy required for the process. Another explain why electrolysis of aluminium oxide produces large quantities of carbon dioxide. This is all to do with the electrode, because within aluminium oxide as a compound there is no carbon. So being very clear on that. So we know that positive electrode is made of carbon. Again, that's factual, learn that. Oxygen is made at the positive electrode because of oxide ions. And at that situation, the carbon and the oxygen will react together at the electrode, and then carbon dioxide gas will form. Okay, and that also erodes the electrode, and it can reduce in mass. Here we have explain why hydrogen gas is produced at the negative electrode in the electrolysis of potassium chloride solution. Key thing is here solution, because there is no hydrogen or ions of hydrogen within potassium chloride itself, but there is in water. Water breaks down into hydrogen ions H+ and hydroxide ions HO-. Okay, and that's where the hydrogen gas comes from when 2 hydrogen ions bond together to form a molecule of hydrogen gas H2. So the reasons why these are a little bit trickier, and it's a 4 marker. So I recommend understanding this as much as possible, doing some further work on this if you haven't come across this before, and paying attention to the steps. So first bit is water molecules break down and will release hydrogen ions. These are crucial to form hydrogen gas, and they are discharged at this point because potassium is more reactive than hydrogen. Now, often this is a sticking point in understanding, and sometimes it's conceptually tricky. My advice at this point is write it down and learn it as you go through it. It will sink in as you go through. We know that the hydrogen ions will gain the electrons and therefore will form hydrogen molecules, H2, and therefore are no longer ions because they don't have a charge. And a half equation for the production of chlorine gas, as an example, at a positive electrode. So there's nothing there for you. It's totally blank. So we have got the chloride ions. They will form chlorine gas. And in the process, we have got then two electrons that are released as well. Okay, another 4 marker and another explain. So these tend to come towards the end of a longer question. Here we have explain how copper is produced from copper 2 sulfate solution by electrolysis. Again, massively important, the word solution. It's copper sulfate dissolved in water. Therefore, there are 4 types of ion here. Copper, which is Cu2+, sulfate, which is SO4 2-, hydrogen ions, H+, and hydroxide ions, OH-. And so we know copper being a positive, or is a positive ion because it's a metal. They are attracted to the negative electrode because opposites attract, and the copper will gain electrons in its ionic form and become solid copper, and making copper ions which get deposited on the electrode. And they're your 4 marks. So have a little reflect of what you've just been through. You can go back, there's various bits in the notes to fill in. Hopefully you will have come across similar reflections yourself in terms of recapping what the process of electrolysis is, knowing the electrodes, that should say anode, not anion, sorry. So that's a typo there. And being more familiar with the different ionic compounds that you can come across that may feel unfamiliar, but can be an example of an electrolysis, whether it be molten or in a solution. So it's really useful to have a look at those. And then do have a think about what your even better if is. It might be to watch that required practical and make some notes. It's totally up to you because it's your learning. So I hope you found that useful.